Somewhere in the universe, there may already be a civilization so ancient that human history would seem like the blink of an eye, a society that watched stars ignite and die before Earth even formed oceans, a civilization that has seen galaxies slowly reshape themselves across millions of years. If beings like that exist, one question refuses to disappear. Where are they? It's a question that has inspired countless movies and novels, but it's also one that some of the world's greatest physicists have spent decades trying to answer, not with wild speculation, but with mathematics. And the more seriously science examines the problem, the stranger the answer becomes. Because the very laws of physics that appear to make contact almost impossible are the same laws that describe exactly how it could happen. That contradiction has fascinated scientists ever since a famous lunchtime conversation in 1950 sparked what we now call the Fermi paradox. Since then, researchers have tried to understand why a universe filled with billions of stars appears so silent. But maybe we've been asking the wrong question. Instead of asking why nobody has visited us, perhaps we should ask something even stranger. What would arriving actually mean in a universe where nothing, not information, not matter, not even light itself, can cheat time? To understand that, we first need to realize something astonishing about the night sky. Every time you look up, you're looking backward. The stars scattered across the darkness aren't showing you the universe as it exists now. They're showing you fragments of history. A nearby star may appear exactly as it did 4 years ago. Another could be revealing light that began its journey thousands of years before the first cities were ever built on Earth. Some of the stars you admire may not even exist anymore. They could have exploded centuries ago, yet their final light is only reaching us today. The universe has no live broadcast. Everything arrives late. Every beam of light is an old message. Every galaxy is a photograph frozen somewhere in time. That changes the way we should think about alien civilizations. People often imagine first contact as an instant event. A spacecraft appears, a signal arrives, humanity reacts. But space doesn't work that way. Imagine mailing a letter that takes thousands of years to reach its destination. By the time someone finally opens it, the person who wrote it is long gone. Their language may have changed beyond recognition, their civilization may have transformed or disappeared entirely. Communication across the cosmos isn't a conversation. It's archaeology. When astronomers search for signals from distant stars, they're not really listening for someone speaking today. They're searching for echoes from civilizations that existed centuries, thousands, or even millions of years ago. This is why enormous radio observatories continue scanning the heavens night after night. They're not waiting for a phone call, they're searching for ancient messages still traveling through space. And that leads to an unsettling possibility. What if contact has already happened? Not with giant spacecraft hovering over cities, but with a signal that swept past Earth before humans even existed. Imagine a civilization broadcasting toward our solar system hundreds of millions of years ago. The transmission arrives while dinosaurs rule the planet. Nobody is there to hear it. The message continues through space, unnoticed. Physics doesn't require anyone to be listening when a signal arrives. It only requires the signal to keep traveling. That's an extraordinary thought. Perhaps the universe has already spoken countless times. Perhaps we simply weren't around when it did. This changes the question completely. Instead of asking whether aliens can reach Earth, we should ask something much deeper. How do you define arrival in a universe where every message is delayed by time itself? Because every signal, every probe, every photon that reaches us is carrying history, not the present, the past. And once you understand that, another realization begins to emerge. Maybe distance was never the greatest obstacle between civilizations. Maybe time has always been the true barrier. The simplest explanation seems obvious enough. Space is unimaginably large. Even traveling at incredible speeds, the distance between stars is so vast that crossing it appears almost hopeless. Light itself, the fastest thing the universe allows, moves at nearly 300,000 kilometers every second. Nothing with mass has ever been observed traveling faster, and according to everything modern physics has confirmed, nothing ever will. That limit isn't just a technological challenge. It's woven into the fabric of reality. As an object accelerates closer and closer to the speed of light, pushing it just a little faster demands dramatically more energy. The closer you get, the steeper the cost becomes. Eventually, the required energy climbs so rapidly that reaching light speed becomes physically impossible. For generations, this has seemed like the end of the story. If no one can outrun light, then no civilization, no matter how advanced, can simply hop across the galaxy whenever it chooses. Consider our own cosmic neighborhood. The nearest star beyond our Sun, Proxima Centauri, is just over 4 light years away. That sounds close until you compare it with the fastest spacecraft humanity has ever built. At those speeds, reaching our nearest stellar neighbor wouldn't take decades, it would take thousands of years, and that's only the closest star. The Milky Way stretches roughly 100,000 light years from one side to the other. At first glance, the conclusion seems unavoidable. The galaxy is simply too big. Even intelligent civilizations would remain isolated by distance alone. Case closed. Except there's a hidden assumption buried inside that argument. One so natural that most people never think to question it. It assumes that time passes identically for everyone. It doesn't. This is where Albert Einstein completely changed our understanding of the universe. His theory of relativity revealed something almost impossible to accept at first. Time is not universal. It doesn't tick at the same rate everywhere. How quickly time passes depends on how you're moving. The faster you travel, the more your experience of time begins to separate from everyone else's. At ordinary speeds, the effect is so tiny that we never notice it. But, as velocity approaches the speed of light, the difference becomes extraordinary. Imagine a spacecraft capable of traveling at 99.9% of light speed. Observers on Earth would watch the journey unfold over years. But inside the spacecraft, the crew would experience far less time. Their clocks would run slower, their bodies would age more slowly. To them, the voyage might feel surprisingly brief. Push even closer to light speed, and the gap grows astonishingly large. What looks like decades from Earth could feel like months on board. What appears to be centuries outside the ship might become only a handful of years for the travelers themselves. This isn't science fiction. Particle accelerators demonstrate the same principle every day. Subatomic particles traveling near light speed survive far longer than they should because, from their own perspective, less time has passed. Nature has already confirmed the mathematics. Now imagine extending that principle to an advanced civilization. Suppose a species mastered propulsion far beyond anything we can currently build, not faster than light, that remains forbidden, but unimaginably close to it. From our perspective, their expedition across the galaxy would still require tens of thousands of years. Entire empires could rise and collapse while they traveled. Languages would evolve, continents would change, civilizations would be born, flourish, and vanish. But aboard their ship, only a few years might pass. The travelers would not feel as though they'd crossed 100,000 years of history. They would simply complete a long voyage. And when they arrived, they wouldn't feel like explorers. They would feel like people who had left home only a short while ago. Yet everyone they had ever known would be ancient history. In a very real sense, they would have traveled into the future, not by breaking the laws of physics, but by following them perfectly. This is the paradox at the heart of interstellar travel. From Earth's perspective, crossing the galaxy seems almost impossible. From the traveler's perspective, it may be remarkably practical. The obstacle was never merely distance. It was always whose clock you choose to measure. And once you realize that, the possibility of alien visitors begins to look very different. The question is no longer whether a civilization could endure a journey lasting thousands of years. The better question is whether they could build a spacecraft capable of surviving it while barely aging at all. If the answer is yes, then perhaps the universe has never been as unreachable as we imagined. Let's imagine for a moment that somewhere in our galaxy a civilization has existed not for thousands of years, but for millions. Human civilization has gone from stone tools to space telescopes in just a tiny fraction of that time. So what might a species accomplish with a million-year head start? The honest answer is simple. We have no idea. Their technology could be so far beyond ours that trying to describe it would be like asking someone from the Bronze Age to imagine the internet. They might understand the individual pieces, but not how those pieces fit together. Even so, the laws of physics still give us clues. Whatever they build must obey the same universe we do. Energy must be conserved. Information cannot travel faster than light. Matter still has mass. Those rules don't disappear just because a civilization becomes more advanced. In fact, the smartest engineers don't fight the laws of nature, they learn to work with them. And that leads to a surprising prediction. If an ancient civilization ever explored the galaxy, the first thing to arrive probably wouldn't be a massive starship filled with passengers. It would be something far smaller, a robotic probe. Think about the way humans explore our own solar system. We didn't send astronauts to Jupiter first, we sent machines. Tiny, durable, relatively inexpensive explorers capable of traveling for decades without food, air, or sleep. For an advanced civilization, the same logic only becomes stronger. Why risk living beings on journeys spanning centuries when autonomous probes can travel indefinitely? Better yet, why send just one? Imagine a machine no larger than a grain of sand. It lands on an asteroid, gathers raw materials, and quietly builds copies of itself. Those copies spread to neighboring asteroids, each creates more copies. Over thousands or millions of years, an entire network of self-replicating explorers slowly expands from one star system to the next. No rush, no urgency, just relentless patience. This idea isn't science fiction. Physicists and computer scientists have seriously discussed the possibility of self-replicating interstellar probes, sometimes called von Neumann probes, as one of the most practical ways an advanced civilization could explore the galaxy. Once released, they wouldn't need constant supervision. They could operate for geological timescales, waiting, watching, recording. If something like that existed, it wouldn't necessarily announce itself. It might quietly monitor developing civilizations without ever interfering. From its perspective, waiting another 100,000 years could be insignificant. After all, what's another millennium to a machine designed to function for millions? That's a difficult idea for us to grasp because human lives are so brief. We instinctively expect events to happen on our timescale: weeks, months, years. The universe doesn't care about those units. Its clock moves much more slowly. Now consider another possibility. Suppose one of these probes entered our solar system millions of years ago, long before humans evolved. It might have settled onto a small asteroid, hidden itself among countless ordinary rocks, silently observing as Earth's history unfolded. It would have watched dinosaurs disappear, ice ages come and go, early humans learn to make fire, cities emerge, radio signals begin leaking into space. Perhaps only then would it recognize that intelligence had finally appeared. If that sounds extraordinary, remember that from the probe's perspective, it has done almost nothing at all. It simply waited. The passage of millions of years means little to a machine that doesn't age. This changes the meaning of first contact. Perhaps contact isn't a dramatic arrival from deep space. Perhaps it's the moment we become advanced enough to notice something that's been here all along. And that possibility brings us back to one of science's oldest mysteries. If civilizations capable of building technologies like these are possible, why don't we see any evidence of them? Why does the galaxy appear so empty? That single question became famous after physicist Enrico Fermi casually asked it during lunch in 1950. The universe is unimaginably old. The Milky Way contains hundreds of billions of stars. Many of those stars formed billions of years before our Sun. Even if intelligent life is incredibly rare, simple arithmetic suggests someone should have had an enormous head start, enough time to explore vast portions of the galaxy many times over. So where is everybody? It's a question that has never received a definitive answer, not because scientists lack ideas, but because every possible answer reveals something profound about our place in the cosmos. And perhaps the strangest explanation of all has nothing to do with distance and everything to do with timing. At first glance, the silence of the universe feels impossible. Our galaxy alone contains somewhere between 100 and 400 billion stars. Around many of them orbit planets, and over the last few decades, astronomers have discovered that planetary systems appear to be the rule rather than the exception. Now widen the view. Beyond the Milky Way lie trillions of other galaxies, each filled with billions of stars of their own. The numbers quickly become overwhelming. Even if intelligent life emerged on only one planet out of every billion stars, a remarkably pessimistic estimate, there should still have been countless civilizations throughout cosmic history. So why does the universe seem so quiet? This question became known as the Fermi paradox, but it's less of a paradox than a reminder that our intuition often fails when confronted with cosmic scales. One of the most famous attempts to approach the problem came from astronomer Frank Drake. Instead of asking whether alien civilizations exist, Drake proposed breaking the mystery into smaller questions. How often do stars form? How many have planets? How many of those planets could support life? On how many does life actually appear? How often does intelligence evolve? And perhaps most importantly, how long does a technological civilization survive? That final question may be the most important number in the entire equation. Imagine two civilizations separated by only a few thousand light years. On paper, they seem practically next door. But suppose one reaches its technological peak 200 million years before the other. By the time the younger civilization develops radio telescopes, the older one has already disappeared. Its cities have crumbled into dust. Its home planet has changed beyond recognition. Perhaps even its star has evolved. They occupied the same galaxy. They simply never occupied the same moment. It's a bit like two lighthouse keepers working the same coastline thousands of years apart. Each faithfully shines a beacon into the darkness. Each waits for someone to answer, but their lights never overlap. Neither one ever knows the other existed. This may be the greatest obstacle in the search for extraterrestrial intelligence. Not distance, not technology, time. Human history spans only a few thousand years. Radio communication has existed for little more than a century. Against a universe nearly 14 billion years old, that is almost nothing. If another civilization's own technological era lasted 10,000 years before transforming into something entirely different or vanishing altogether, the chance that our brief window overlaps with theirs could be astonishingly small. We often imagine civilizations as permanent fixtures. The evidence from our own history suggests otherwise. Empires rise, empires fall, languages disappear, knowledge is lost and rediscovered. Technology accelerates in unpredictable ways. Project that uncertainty across millions of years, and it becomes impossible to assume any civilization remains unchanged for long. Some may destroy themselves, others may abandon technologies we would recognize, some might migrate beyond the places we're searching, others could choose silence over broadcasting their existence across the galaxy. There is another reality that is easy to overlook. Even if a civilization wanted to announce itself, the universe makes conversation painfully slow. A message sent across 10,000 light years requires 10,000 years simply to arrive. A reply takes another 10,000. One exchange consumes 20 millennia. Entire civilizations could emerge and disappear between a question and its answer. Perhaps that is why the sky feels empty, not because no one has ever spoken, but because every voice echoes through such immense stretches of time that meaningful conversation becomes almost impossible. The universe may not be silent at all. It may simply speak too slowly for creatures whose lives are measured in decades. That realization changes something fundamental. Instead of picturing the cosmos as an empty wilderness, imagine it as an immense library. Every civilization writes its own story. Each carefully places its book on the shelf. But the shelves are separated not only by space, they're separated by millions of years. Most books are never read by their author's contemporaries. Many remain unopened forever. And somewhere among those shelves, our own story has only just begun. We've been broadcasting radio signals for barely 100 years. Those signals have traveled only about 100 light years into a galaxy that stretches nearly 1,000 times farther across. In cosmic terms, humanity has only whispered. The vast majority of the Milky Way has no idea we're here, which means another unsettling possibility begins to emerge. Maybe we aren't being ignored. Maybe our introduction simply hasn't arrived yet. Even if a civilization possessed unimaginable knowledge, it couldn't simply ignore the laws of physics. The universe doesn't make exceptions for intelligence. Every spacecraft, no matter who builds it, must still overcome the same challenges written into nature itself. And those challenges are staggering. Traveling between stars isn't like flying through empty space. Interstellar space may look like a perfect vacuum, but it isn't truly empty. It's filled with microscopic dust particles, stray atoms, and high-energy cosmic radiation. Most of the time, these particles are harmless, until you start moving close to the speed of light. At those velocities, something as small as a grain of dust becomes extraordinarily dangerous. A particle no larger than a speck of sand can strike with the energy of a powerful explosive. Multiply that by billions of tiny impacts over decades of travel, and suddenly every meter of a spacecraft becomes a shield, fighting an endless barrage of invisible bullets. Then there's the problem of heat. No engine is perfectly efficient. Every burst of energy produces waste heat, and in the vacuum of space, there's no atmosphere to carry that heat away. A starship accelerating for years would have to radiate enormous amounts of excess energy without cooking the very systems keeping its crew alive. It's a challenge unlike anything we've ever faced. Power generation, radiation shielding, structural materials, navigation, life support, each problem is difficult enough on its own. Together, they become one of the greatest engineering puzzles imaginable. Yet none of these obstacles violate physics. They're brutally difficult, not impossible. That's an important distinction. Science often separates problems into two categories: things that cannot happen and things that are simply unimaginably hard. Flying faster than light appears to belong in the first category. Crossing the galaxy at a significant fraction of light speed belongs in the second. One is forbidden. The other demands technology so advanced that, from our perspective, it would almost look supernatural. Arthur C. Clarke famously observed that any sufficiently advanced technology is indistinguishable from magic. But perhaps what truly separates advanced civilizations from young ones isn't magic at all, it's patience. Humanity measures ambitious projects in years, sometimes decades. We celebrate bridges that take 10 years to build, space telescopes that require 20. Imagine instead a civilization willing to plan for 10,000 years, or 100,000, a society that views a millennium the way we view a weekend. Many of the problems that seem impossible to us become far less intimidating when time itself is no longer scarce. Instead of rushing across the galaxy, they could move steadily. Instead of fragile missions, they could build systems designed to repair themselves generation after generation. Instead of relying on biological lifespans, they could create machines that never grow old. Perhaps that's why we continue imagining alien visitors as dramatic arrivals in gleaming spacecraft. It's a very human expectation. We assume intelligence values speed because we do, but nature often rewards efficiency instead. A civilization millions of years older than ours may have learned that the fastest solution isn't always the smartest one. If your technology can survive for millions of years, why hurry? If your explorers can patiently drift between stars while civilizations rise and fall beneath them, then time ceases to be an obstacle. It becomes a resource. And suddenly, the image of first contact begins to change. Not fleets of ships descending through Earth's atmosphere, not flashing lights over major cities, but a quiet discovery, a strange object hidden in deep space, an artificial signal buried inside what once seemed like random noise, a probe that has been waiting longer than human civilization has existed. The greatest encounter in history might not begin with an arrival. It might begin with a realization. The realization that whatever came looking for us arrived long before we learned how to look back. And if that's true, then perhaps we've misunderstood the universe all along. Not because we've underestimated its size, but because we've underestimated its patience.